Here in 6.3 we want to discuss something called the central limit theorem, which again applies to sampling distributions. Recall that we only need the mean and the standard deviation to describe a distribution, at least a normal distribution. And so we would like to know when our sampling distributions are normal. So properties of the sampling distribution for x bar, we'll abbreviate that sometimes as SDSM, sampling distribution of the sample mean, for sample size n, or the x bar distribution. So if mu is the population mean and sigma is the population standard deviation, then the mean of the x bar distribution, so the expected value of x bar, is equal to mu. And then the standard deviation of the x bar distribution is the population standard deviation divided by root n. So note here, as n increases, as your sample size increases, the standard deviation or standard error of the sampling distribution decreases. And then we have a theorem here. If the x distribution, the parent distribution, is normal, then the x bar distribution is going to be normal for all sample sizes. So if you start with normal, you get normal. So let's look at an example. Let's say the parent distribution has a mean of 100 and variance of 16. N is 225. We want to find mean and standard deviation of the x bar distribution. So mu sub x bar is just mu, the population mean, which is 100. And then if sigma squared is 16, that means that sigma is equal to 4. So then our sigma x bar, the standard deviation of the sampling distribution, is going to be sigma over square root of n, which is 4 over root 225. And if you compute that, you get approximately 0.27 to 2 decimal places. So note the standard deviation of the sampling distribution is smaller than the standard deviation of the parent distribution. And as sample size increases, this will get even smaller.